Okay, we start. Student at the back, can you see clearly? Okay, we start with chapter 1, sustainable process design. Now, from the learning outcomes, these are the learning outcomes 3. Yes, any more discussion that you want to discuss? Any questions? Are you ready for the lecture? Not ready, you just follow if you're not ready. Okay. Okay. First thing first, what is sustainability? Okay, as mentioned earlier, the one so that you can sustain the process in terms of the environment, social, and health. Okay, there are sustainable pillars, sustainability pillars. There are 3 pillars. Okay, later you see. So why it is important for us to sustain the environment? Okay, we go slide by slide first. It is required a transition in human attitudes, okay, toward the environment and a shift in behavior. So it can lead to better future for the planet. So now, current process, you do it, design it as sustainable process, it will benefit for the future human and planet. Okay. Okay, what is sustainability? It touches about the quality of the life on Earth. Okay, the efficient use of the earth materials, your raw materials. So you should consider whether it is sustainable or not to your process. Then the protection of global commons, management of human settlements. Here means if you set up the plant over there, whether it will impact the settlement nearby. Okay, whether the location is suitable or not. That's why in your PDP, you have a site selection. You must choose wisely so that it doesn't impact on the settlement around your plant. Okay. Then chemicals and management of the waste. How you manage your waste. Is there any waste produced? It is impossible for the process to not having the waste. Theoretically, perhaps you can recycle 100%, but practically, in real life, there must be some waste produced, either wastewater or air or solid. Okay. Then sustainable economic growth, how your process can contribute to a sustainable economic growth. Now, these are the 3 pillars of sustainability: environment, economic, and social. So your process must touch all of this, involve all of this. Okay, the ecological satisfactory solution, limiting economic activity, cutting down waste. Okay, how you can recycle or reuse your waste. Investing in technology that could limit and render the waste harmless. Okay, you can invest in designing the wastewater treatment plant to have a better treatment with which meet the sustainability pillars. Okay. Then ensure the population growth does not exceed the economic capacity to evolve in accordance with the environmental requirement. Okay. Now, sustainable development, the development that meets the need of the present without compromising the ability of the future generations. What you do now will not compromise, will not jeopardize the future generation. Okay. Okay, we have a few industrial revolution from the first up to fourth. Now I think we are going to the fifth already. Okay, moving to it. Now, what is it about? It released billions pounds of toxic waste into air, water, and soil. It creates materials that cause concern by future generations to their quality of life. Produces large amount of waste, requires endless regulations to simply regulate the rates of damage. Okay. Now, what's the point to move to EV, electrical vehicle? What's the main concern? What? What? Only eyebrow move. What's the answer? What do you think? There is no right or wrong. I just want to know your opinion. Why we need to move to EV? Not need to move. There's alternative. For air pollution. How will impact? Combustion, release of CO2. Release of CO2. Current vehicle using gasoline involve fuel and combustion. It releases CO2 mainly. Okay, and it might release some other gases. So, converting to EV, what will be released? Anyone drive EV car? No. Yes. What will be released? H2O. H2. H2 release. That's something for you to think about. Why is the mass to? I'm not saying the mass. They are moving towards that. Okay. Okay. My question. From gasoline, move to EV to reduce the air pollution. How about the battery of the EV? Will it contribute to solid waste later on? Then another type of pollution. Okay, there are arguments on that. You can look through. Okay. Now, these are the objectives of a sustainable design. Please take note on these objectives. You must understand and be able to explain each of the objectives. Okay, the first objective is to focus on the resource conservation. Resource conservation, what is your raw material? Then recycle and reuse, how you can recycle your raw material, your waste. Okay, pollution prevention, how you can prevent pollution from your process. You cannot keep on the waste produced, but perhaps you can manage on your gases, the waste produced. If it exceeds the limit, So what you need to do? Okay, then profitability enhancements, how it will generate the income from your process. Yield improvement, from the process, how it can improve the yield. Okay, and then 6, capital productivity increase and debottleneck, how it can increase the capital productivity and how it can solve the debottlenecking problem. Okay. 7, quality controls, assurance and enhancement, how you can control your product. What are the methods to control your product? Okay. Next is process safety. If you were to how to say, in your internship, is there any safety issue occur? Safety issue. For example? For example? Handling acids. They might. Yes. You must wear proper PPE, right? The one in acid plant. How about others? Any safety issue has been highlighted during your internship? No idea. Safety is the most, one of the most important in industry. Okay, if you mingle around with the industry people, safety first. Then safety is important as the money, the profit. We cannot jeopardize the safety of the workers, of the people around in order to increase the profit. Okay, that is wrong. Okay, so these are the key drivers for process engineering research development and changes in the primary chemical process industry. Okay, first chapter is a lot of theory part. You need to memorize the objective, the key points, everything. Okay, first is reduction in raw material cost, how you can reduce the raw material cost by purchasing it or by perhaps, let's say you are using agriculture waste, biomass, right? Perhaps you can plant it, okay, if it is feasible. Okay, number 2, reduction in capital investment. For example, distillation column. Do you need 2, 3, 4, or 5? It involves the capital investment. It affects the capital investment. Okay, next is reduction in energy use. Whether to have in distillation column, is it better to have 2 distillation column or increase the stages? Okay, it involves the energy. From the energy, it affects the cost as well. Okay, increase in process flexibility and reduction in inventory. How flexible is your process? Let's say your reactor you design for HCl acid. Can you use other type of acid? If let's say HCl is not applicable, so can you use sulfuric acid for your reactor? Will it be any effect to the reactor or to the whole process line or not? Okay. Then emphasize on the process safety. Increase attention to the quality, okay, the yield of the product. Then better environmental performance. Again, the waste, okay. So all these things involved in the process integration. Process design, retrofitting, and operation that emphasize of the unity of the process. What is retrofitting? Have you came across this term before? Retrofitting. Retrofitting. Google lah. What does it mean by retrofitting? I want to know from your side. What is retro? Correct. Modifying the existing plant. We call it as retrofit. So you already have your plant. You want to optimize it. So you do retrofitting. Instead of you start from scratch, starting a new plant. Okay. Okay, a chemical process is an integrated system of interconnected units and stream. So all the unit of the stream are interconnected. Proper understanding and solution of process problems should not be limited to symptoms of the problems, but should identify the root causes of this problem by treating the process as a whole. Okay, you should not limit it to symptom of the problem. Let's say your reactor, alarm occur on the pressure controller. It said high pressure, exceed limit. What would you do? Not exceed limit. If exceed limit or will explode, it reaching to the higher range already. Alarm will sound. What will you do? Or what do you think you should do? The pressure controller has been installed. Then the pressure is higher, approaching the higher range. So the alarm make the noise already. So from there, what you should do? Huh? For example, you boil water in kettle. Once it start to boil, not that one. Boil water manually in the, do you know the kettle that makes sound when it boils water? Okay. When it makes sound, once the water boil, it will make sounds. So what you should do? What you should do? Just turn off the gas. Okay, that one for that case lah. If a reactor, you cannot simply shut down. Pressure relief valve. Turn on the pressure relief valve. Yes, correct. That is the solution. Okay, but that you focus on the symptom. Pressure high, open on the pressure relief valve. But then you need to know what caused the high pressure, the root cause. Perhaps is there any something wrong with the process? Any leaking somewhere from the feed? So you need to find out the root cause. What caused the pressure to increase? Okay. Okay, effective improvement and synthesis of the process must account for this integrated nature. Now, process integration, it involves these activities. We start with the task identification. Okay, first step, task identification. First step, explicitly express the goal to achieve and describe it as an actionable task. Okay, for instance, these are the tasks. Pollution prevention, reducing certain discharge of the process to a certain extent. Okay, pollution prevention. Or quality enhancement, to reach a specific composition or certain properties of a product. Okay, this one perhaps to increase the yield. Or increase the purity. Okay, the first one, pollution prevention, perhaps to reduce the concentration of CO2, for example. Okay, reduce concentration of the COD of your wastewater. Okay. Now, next, targeting. Once we identify the task, next we target. Refers to identification of performance benchmark ahead of detailed design. Okay, before we have detailed design, we must do the targeting first. Okay, this is to determine how far the process performance can be pushed and shed useful insights on the exact potential and realizable opportunities for the process. Okay, and this one useful in comparing the sustainability metrics with the ultimate performance. Okay, for example, we have just now task identification. For example, let's say to increase the purity. Okay, the task, increase the purity of your product. So target, what you should target? Increase by how many percent? Okay, percentage. What is the percentage? Then amount. Then what is the cost? Okay. Then what is the cost lah, basically the cost, amount and percentage. For example, this is for purity of the product. Okay, then generation of alternatives, synthesis. Just now we want to increase the purity. Now let's say we set target to increase the percentage of purity. Let's say from 60% to increase to 90%. Okay, this one is just a simple example. Then generation of alternatives, synthesis. So what are the reactions involved? Reactions, you must compare few reactions. Okay, enormous number of possible solutions to reach the target. And then the generation of such design alternatives and representation effectively handled through process synthesis. Okay, which involve putting together separate elements into a connected or a coherent whole. Okay, here are the points. Let's say to increase the purity, how should the streams can be rerouted? This one from the existing plant. Let's say from existing plant. Okay, what are the needed transformation? Any separation or reaction to be added, to be removed or what? Okay, should we use separation to clean up the wastewater for reuse? Okay, is this feasible? Okay, what technologies should be employed? To increase the purity, is there any current technologies perhaps rather than distillation column? Okay. Then which solvent or what type of distillation column? Okay, so should you change the operating conditions? Okay, these are the examples only. It depends to your task. It is not compulsory to tick all. Okay, it depends to your task. Okay. Then which of the many available component parts should use? How they should be interconnected to structure the optimal solution. Okay, you should think through how they can be interconnected with each other in order to increase the purity of your product. Okay, then the flow sheet of the system is generated to meet certain objectives. Okay, this one on the process synthesis. Here. Aim of process synthesis is to optimize the logical structure of a chemical process. Okay, specifically the sequence of steps. In the example just now, to increase the purity. So how you can optimize your plant to increase the purity of your product? Okay, choice of chemical, if it is applicable. Okay, source and destination of recycle stream, if it is applicable. Okay, the process inputs and outputs are known. Input and output, when you have your process as a big picture, okay, this is the process. What is your input? Identify your input and identify your output. And to revise the structure and parameters of the flow sheet. This one for retrofitting design. Okay, or create a new flow sheet. Okay, you should choose which is applicable to your task. Okay. So far? Can Now, after you come up with the alternatives, the first, just now, the previous step is generation only. You brainstorm what are the process that can increase the purity of your product. Come up with the process first. Then only you select of the alternative synthesis. Okay, from here, you have to do the selection step. Extract optimum solution from the among possible alternative. Okay, let's say you want to increase the purity. Use distillation column or use evaporator, for example. Or use any type of separation equipment. So from there, which one is more feasible? Okay, this step is typically guided by some performance metrics, assist in ranking and selecting the optimum alternative. As I said just now, let's say distillation, evaporator. So what are the costs? How many distillation column you need? How many evaporator you need? How big you need? What is the energy involved between these two? Then from there, select the most feasible one. Okay, so this one, generation and selection of alternatives are process synthesis activities. You must do this first before you start your optimization activities. Okay, so from there you select, then you analyze the selected alternative. Let's say you, from distillation and evaporator, let's say you calculate, do the feasible study, come out distillation is more suitable to increase the purity. Then on the distillation column, you analyze in detail what type of distillation, how many stages, what is the reflux ratio, how you do the sequencing. Okay, then we go into detail on that selection. Okay, so that is on the analysis of the selected alternative. Okay, next on the process analysis. Okay, just now, as I mentioned, it may involve predicting and validating the performance using experiment at the lab, perhaps pilot plant scale, and even actual runs of existing facilities. Okay, process input along with the process structure and parameters are known, while the goal is to determine the process output. Okay, so these are some common techniques on the analyzing the selection just now. For the distillation, just now we already choose the distillation. So what is the safety precautions, safety review for that distillation column? What is the techno-economic analysis? What is the cost, the capital cost, the utility cost? Okay. Process synthesis and process analysis serve as the two primary pillars, okay, for the sustainable design through process integration, with synthesis generating alternative and analysis evaluating alternative. Okay, so this works for new plant and also the retrofitting. Any questions so far? Too much info. Boring. Sleepy. Hungry. Okay. Okay, last slide lah, last slide. Last slide. Okay, this one to show you. Let me make it bigger. Okay, this production of methyl chloride, C2H3, Cl. Not aviation fuel, not aviation fuel yet. This is only methyl chloride. Okay, this one production of this from the raw material, ethane. Sorry, this is ethyl chloride. Ethane react with the chlorine. Okay, this is the raw material. This is the input. Okay, input. This is your output. Okay, this whole thing in the first place is your process. Okay, first, here you see selection of the processing mode, whether it should be continuous or batch. Okay, how to fix the chemical state of the raw materials, product, and byproducts, everything. What unit ought to be used? If you see from the process over here, there are a few unit operations involved. How to select them? Okay, then comes with the synthesis step. These are the important synthesis steps. Eliminate differences in molecular types. Distribute chemicals by matching the sources and sink. Eliminate differences in composition. Okay, I will go into details in the next topic. Okay, how to do all these synthesis steps. Eliminate differences in temperature, pressure, and integrate tasks. How you can integrate the streams to optimize the energy usage. Okay, so from this process, you need to identify what is the capacity, how many units per unit time go through each task. Okay, is the process as a whole. Okay, what is the bottleneck and what is the throughput time? Okay, all these things you should take into consideration. I have uploaded in Teams all the notes. Huh? Is it? Have I? The notes already in Teams. Okay, the notes already in Teams. Download the notes. You compare between this PFD and this PFD. What are the difference? Because it asks, okay, see here, this one versus this one. So check out what are the difference. Okay, I want you to go through and see what are the difference. We discuss in the next class. Okay. Any question before we left? Okay, so that's all for today. Hopefully you can grab as much as you can. I will upload the recorded lecture in CN so you can go through again and understand. Okay, that's all. Thank you. Wait, wait. I missed out.